All right, let's dig into conditional statements in geometry. As you learned last night in your homework, a statement that can be written in a blank form is called a conditional. If, then. And let's call this day 11. Please add up here, day 11. Now, what we're going to discover is there is a whole lot of writing on this particular unit. Lots of words, lots of sentences, not traditional math stuff. Therefore, we're going to want some shortcuts. So what we're going to use is P arrow Q. P implies Q. And you can read it either as if P, then Q, or P implies Q. And last night you learned about two phrases to describe the content of these conditional statements. What is the phrase that immediately follows if? Good. The hypothesis. And what is the phrase that immediately follows then? The conclusion. And this always messes with people in science. Why? Because in science, a hypothesis has both an if and a then. If I boil water for 20 minutes, then it will kill the pathogens inside of it. It's got a condition and an expected result. For geometry, though, we're breaking it out. The condition in which it applies is the hypothesis. The conclusion is the resulting scenario as a result of that. So let's take a look at this example. If you live in Nashville, then you live in Tennessee. What's the hypothesis? So close. Oh, someone said it. Yes. If is the indicator of what's coming being the hypothesis. It is not part of the hypothesis. You live in Nashville is the hypothesis. And the conclusion? Good. You live in Tennessee. Okay, would you guys do number 2 yourselves, please? Now, go. Please check your answers against mine on the screen. How are we feeling about this? 5, this is doable. I like this. 3, I can sort of do it. I got to practice a little bit. I'll be better. 1, this is confusing. Great. First step. Okay, hands down. Please take a look at number 4. And I want to write a conditional statement of this as well. What's wrong? Why is it different? There's no if, there's no then. But there's still a nature of conditionality associated with this. So what would be my hypothesis? What's the condition in which I'm talking about? Ben? Do you guys agree that that would work? If an angle's measure is greater than 90, then it's obtuse. Would someone phrase it the other way? If it's obtuse, then the angle's measure is greater than 90. Either of those is fine. You choose which one you want to write here. Okay, please try number 7 now. What would be an appropriate way to phrase this as a conditional statement? Wait.
It is Valentine's Day and you are in February.
Okay. Could I do it the other way? Yeah. If it's Valentine's Day, then it's February. Does everyone agree that works? Valentine's Day is February 14th. That makes sense. Could I phrase this one the other way?
No.
If it's February, then it's Valentine's Day.
No.
No. So we're also going to be talking about counter examples, ways in which you demonstrate that a statement is false. In other words, February 20th is February, but it's not Valentine's Day. So for this one, we'd have to say if Valentine's Day then it is February. And Wade started to say that then you're in February. I'd be totally okay with that. The exact wording is not as important to me as much as the message. Okay, let's go to page 2. We're going to find value in using conditional statements in various forms. So on the top of this worksheet, would you please, above where it says related conditional, write the original one, conditional. And the symbolic form we said is P arrow Q, or P implies Q. Write it above these. We're going to manipulate the conditional in certain prescribed ways, and in doing so, we're going to get some value out of it. But first, let's work on what it looks like when we manipulate them. The inverse is when I negate, by negating the hypothesis and conclusion. So in other words, instead of if P, then Q, I would be saying if not P, then not Q. It's an awful Q. And there's another notation which has a little squiggly like a tilde in Spanish that means not. Next one is the converse. What do you guys think of when you hear the word converse? Shoes, of course, right? So the converse instead is supposed to be the exchanging of the hypothesis and conclusion. So instead of P implies Q, The Q comes first now, and the P follows it. And the way I like to think about this is, okay, I agree that Converse shoes comes to mind. So picture my hands as my 2 feet with Converse shoes on them. And when I walk, first my right foot is in front, then my left foot, then my right foot, then my left foot. They change places, right? And so the same thing happens with P and Q. They change places. What about contrapositive? Well, it's like both of these, formed by negating and exchanging. So I would expect this to look like not P, excuse me, that's not right. Not Q implies not P. Not working. Not Q implies not P. Those of you using flashcards or note cards, each one of these should be on a note card with these structures on the backside for you to memorize. You definitely need to know these structures. So let's do it as an application. Here's a conditional statement. If it's Saturday, then there is no school. Do we buy that? Is that a true statement? Everyone okay with that? Now, there are some of you in here who may end up being lawyers in your life. And you look at that and you say, well, that's not exactly true. Is there a scenario where on a Saturday you could have school? What would you think of as that? Like a detention, or maybe like driver's school, driver's training, or like I went to something called catechism, which is like a religious school. Maybe that would have been on a Saturday. But I'm going to ask that you make your life easier by looking at this and saying, okay, if this is what we're given, I'm going to operate in the world where this is what we're talking about. If it's Saturday, then there is no school. I want you to visualize, if that's true, what kind of school we're talking about. We're talking about like this, high school, normal classes, not detentions. Everyone good with that? So we're just visualizing that world. Okay, what's the inverse then? If not Saturday, then what's the second part? Then there is school, right? Not, there is not no school. And if you wrote if there is not no school, then I would accept it because I understand what you're doing. But I'm okay with you taking a little bit of license in how you write this, right? Like I didn't say it is not Saturday. I just said if not Saturday, because I'm conveying the meaning. Just make sure you're not changing the meaning. Is this true? No? If it's not Saturday, then there is school. Okay, so give me a counterexample. Give me something that satisfies the hypothesis, not being Saturday, while at the same time violating the second part.
Sunday.
Yeah. So you could say false, and then your counterexample would be Sunday. And you'd show that it works for the first part, is not Saturday. But, and then show that it violates this part, is not school. It's a counterexample when it shows that it satisfies the first part and violates the second part. What about the converse? So now we're going to take the original conclusion, put it first. If no school, and the original hypothesis is now the second part, then it is Saturday. True or false? True. Again, we get the same counterexample, don't we?
Or it could be like a school day, no school, like a Monday, no school.
Like July 4th, right? Middle of summer. So Sunday has no school, but isn't Saturday. That shows us that this is not true. All right, what about contrapositive? This is flipping it and reversing it, right? So if then, what's the part in front? There is school, then not Saturday. Sorry, that green is hard to read, isn't it? If there is school, then it's not Saturday. True or false? This time it's true, isn't it? I cannot think of an example where there is school and it's not and it is Saturday. Because if it were Saturday, then there shouldn't be school. We accepted that as true to start with. Any questions on this process? All right, last piece for today. Another structure of conditionals is something called a biconditional. And notice here, it's saying that both P implies Q. This is a logic symbol called, or that means and Q implies P. It's got to work both ways. So our notation is P with a double-headed arrow Q. And that's read as P if and only if Q. This could also be written as P IFF Q. And it's only true, a biconditional is only true when both the conditional and the converse are true. So it's like a double whammy. In order for the biconditional to be true, it's got to have both parts be true, which is why the definition of this is it's a conjunction, meaning an and, of the conditional and the converse. Yeah. So, for example, remember when we talked about the supplementary one? Shows up when we did? Obtuse, right? Here we said if an angle is obtuse, then its measure is greater than 90. And we recognize that it could have gone the other way as well. If it's greater than 90, then it's also obtuse. This is an example of a good biconditional, but the Valentine's Day is not, because it only works one way. If Valentine's in February, but it doesn't work to say February than Valentine's. Okay, so please try number one yourselves now. All right. So what's the conditional? Good. We see the if and only if, so we go to the first part. Two angles are supplementary. And because I'm writing conditional, I'm going to put if in front of that, and then in front of the second part. The sum of their measures is 180 degrees. Question, Wade? No? How about the converse? Now, this isn't fully comprehensive, but does it convey the same idea? Yeah. If you start to get a hand cramp, feel free to shorten it up, but keep the idea consistent. Don't lose critical details. Now, let's go back to our conditional. Is the conditional true? If the two angles are supplemented, then their sum of the measures is 180. We agree? True. I'm going to circle and put a T there. What about the converse? If the sum is 180, then we call them supplementary. Also true. If both are true, what's the truth value of the biconditional? True. If, on the other hand, one or both of them was false, then the biconditional is false. It requires both to be true. Okay, please take the rest of the class to finish up this 3-page document, submit it in Canvas when you're done.